Hi, I'm Shamali Chatterjee and I'm presenting Sophia, work done at Purdue University in collaboration with Johns Hopkins University Adobe Research and Argonne National Laboratory and supported by the National Institutes of Health and funding from the Lilly Endowment. So we are doing online tuning of NoSQL databases, and these DBMSs have a plethora of performance-related parameters. For example, Cassandra has about 56 and Redis 46. And the exact setting of these parameters, they determine the performance of the database. And the optimal setting is, again, specific to the application. Now, application characteristics change over time, and that's where we basically want to do the online tuning of the configuration parameters on the fly. And our target is clustered NoSQL databases, for example, Cassandra and Redis. Redis is an in-memory database, so we have two distinct flavors of these NoSQL databases. Now, this is challenging because of the large configuration space and complex interdependencies. The other thing we want to do is we want to see when to instantiate this reconfiguration. For example, if you have a short-lived workload pattern, then reconfiguration may not be necessary. So we have a cost-benefit analyzer embedded in our optimization technique that tells us when to do the reconfiguration while maintaining the data availability. So here you see that you have to look before you change the configuration, and we see that there is a temporary drop in throughput due to the transient unavailability of server instances that has to be taken into consideration. So we have this crossover point such that if the new workload pattern lasts greater than this threshold, then it is worthwhile reconfiguring. So we show that the state-of-the-art static tuners, they actually degrade throughput and degrade data availability, whereas the optimization technique of Sophia has both a workload predictor and a cost-benefit analyzer that tells you when to do the reconfiguration to achieve long horizon optimized performance. And it gracefully executes this decentralized protocol to switch over the cluster to the new configuration while maintaining the data consistency and availability. And we show three different applications. One is the NG-RAST application, which is the largest metagenomics portal hosted at Argonne National Laboratories. And we also have the bus tracking and HPC cluster-based applications. And we show improvements over various baselines. So come to our talk. Our talk is in the afternoon on Wednesday, and then our poster session in the evening on the July 10th. Thank you.